Good afternoon, all. I thought I'd do a Muppet 2 live stream. Oh, let's just adjust the camera a little bit. There's Muppet 2. Because I'm sure that lots of people have questions and would like to know a little bit more about how this works. And I'm quite happy to kind of interactively answer questions on this and adjust knobs and twiddle things and show you how it works. So that's what I'm planning to do. Let me just set up my chat. I can see it on the phone. Just need to see it on my PC because then I can see more of it. So good morning, folks. Hi, hello. Good morning and good evening from Australia. That makes sense. Now, I'm sorry this is a rather inconvenient time for UK viewers because most of you probably at work. Now, Americans, what time is it over there? Yeah, it's probably early morning, so that's not terribly convenient. Australia, probably spot on, isn't it? Sitting down, relaxing in the evening. Yeah. Okay, so let me see why I haven't got any chat. I want a pop-out chat. Pop-out chat. Good, okay, pop-out chat. So, hi from Hungary, hi from the US. Perfect time for Australia, yeah. Yeah, it probably is. 2:36 here in Holland. Yeah, that makes sense. It's 1:36 here in the UK. Good. Okay. So, any questions then about this buck converter Muppet 2 test bed? I might have to adjust the camera down a bit so that you can see the scope, or up a bit so that you can see the actual board. Actually, I wonder if I can come away a bit. I don't think I've got zoom on this. I'd like to be able to, oh yeah, there we are. I'd like to be able to see both meters. This is the output power watt meter. Let's go to input power, P. And the scope, yeah, you can kind of see the scope. You can certainly see the green trace, which is the green LED MOSFET driver. I need some glasses here, otherwise I can't see the screen of my phone. It's a very nice big screen. Hello from Gozo. Hi, John. Yeah, I'm really envious because the weather here has taken a turn for the worse. It's been pouring with rain, and I know that you out there have glorious sunshine. One day, would it be more beneficial to use a dedicated MOSFET driver chip? Absolutely it would. Well, it would from the point of view of efficiency. These efficiency numbers would be better if I had dedicated MOSFET driver chips. But I like the opto-isolator driver because it's easy to build. It's visual because you've got these input LEDs so that you can see where the PWM is. So, for example, if I raise the PWM, you can see the yellow LED goes to the left-hand side. That's fully on. That's this MOSFET on 100%. If I lower the PWM, and you can see the signal, the yellow signal going low, then the LED goes to that side. And this is with this MOSFET completely off. It's drawing no power. There's no power in the output, which is the bulb. Let's put that back to about 50%. I could come up a bit, actually, couldn't I? Because then you could be able to see the scope trace slightly better. I want to be able to see that bulb in the bottom right-hand corner, but you can, can't you? Yeah, that's all right. Now, was efficiency different at 70 to 80% PWM? Yes, it was, because a while back I did a video on the efficiency at different step-down ratios. So if I raise the PWM, that means that the output voltage, we're measuring voltage, but the output voltage will be closer to the input voltage, less of a step down, and therefore it's more efficient. If you go to DC, in other words, if you switch this high side MOSFET on 100%, then effectively we've got no losses at all. You can see there's a slightly lower power in the output. Now, of course, my watt meters may not be absolutely exact. Slightly lower power. You can explain that away by saying, okay, well, there's a little bit of on resistance in that MOSFET. There's a little bit of resistance in the piece of wire that is the inductor, but essentially we've got a piece of wire there, piece of wire there, piece of wire there. This is just a DC circuit. It's just a power supply driving a light bulb. So where are the losses going to come? There really aren't any. As I back this down and have a little bit of off time, then the efficiency goes down. And if I take this right down low, and we saw the graph, didn't we? We saw the Adam's watching live from the gym. Okay, you've got a phone holder on your running machine, have you? That's pretty cool. Yeah, if I take the on time very, very low, then the efficiency gets low. And that's because the system's working harder. It's transferring the voltage, which is 12 volts here. I think I can show that. Yeah, 12 volts there. Let's go back to power. It's transferring that down to, I don't know, a couple of volts here probably. So it's working harder, so it's less efficient at the lower duty cycles, yeah. Lots of pictures of fruit and cake. That's interesting. Right, now what other questions have we got? Yeah, so dedicated MOSFET driver chip would give me more efficiency. And you get better efficiency as the duty cycle is higher. And therefore, there's less of a voltage step down. Remember, when you have a voltage step down, you also have a current step up. Because what you're trying to do, if you had 100% efficiency in this system, then you would have the same input power as output power. Now, if you had that, when you step the voltage down, you step the current up. So this circuit's doing work to step the current up and step the voltage down. So it's less efficient the larger the difference between input and output, voltage or current. What about adjusting frequency of PWM? Right, now frequency, I'm a little bit cornered because if I take the frequency too high, then the rise and fall times of these MOSFET drivers become very significant. So I've had to find a sort of compromise where the rise and fall times of these, which are about 3 or 4 microseconds, are not a huge percentage of the overall wave period. If I take the frequency too low, then of course you need a massive inductor. And so the frequency is about 15 kilohertz. In fact, some people might even be able to hear it. I don't know. But it's a compromise frequency to make the driver losses not too bad and the inductor size not have to be too massive. So yeah, I can adjust the frequency of PWM, not on the fly. I mean, I probably could actually if I had another pot. I could probably modify the code a little bit, and I could actually have a pot for adjusting frequency. Yeah, I suppose I could do that. That's an interesting thought. Are there significantly better opto-isolators? Adam is asking, easily available in 4-pin packages. Well, easily available for me means eBay, and I have been looking. There are plenty of 6-pin opto-isolators, but then I wouldn't be able to have this nice simple circuit. And I'm sure with suitable biasing on the base of the opto transistor. Now on these 4-pin ones, you can't get to the base. It's essentially disconnected. Yes, you can make them operate faster. But I wanted to do it with 4-pin optos. And, you know, I suspect that the issue is simply that the apparently the base of the opto transistor is physically very large because it has to capture a lot of light. And that gives it a high capacitance, and therefore you can't switch it very quickly. Oh, we have a super chat here. Charlton says, "Hi Julian, what are you planning to have as the maximum voltage to go through the system?" Well, what are the limits on voltage? Probably things like the MOSFETs. There may be a maximum voltage they can hold off. The Schottky diodes. Let me just get one of the Schottky diodes. This Schottky diode, for example, is the 90 SQ035. Well, that only has a 35 volt reverse voltage hold off. So if you go over 35 volts, it kind of works like a Zener, and it will start conducting in the reverse direction. How long have you been live? 9 minutes and 55 seconds. So maximum voltage would be determined by things like diode voltages, MOSFET voltages, that sort of thing. I'm not planning to go to huge high voltages because my main interest in this unit is to sort of use batteries on one side, supercapacitors on the other. Now, the supercapacitor modules that I've got peak out at about 16 volts. So I suppose I'm not really planning to go much above 20 volts, that sort of thing. Yeah. Right, any other questions we have? Where has the sun gone today? Yeah, where's the sun gone? We had all these predictions of endless summer, and it's totally gone. It's endless raining now. My solar panels are all mucky, covered in wet leaves, and blossom from the tree, but all damp, and it's horrible out there. Horrid! It's very nice in Scotland. Yeah, I think there's a big band of cloud over the centre of the country, I think. The sun here in Denmark, and you can have it. Yeah, well, I'd have it if I could. Will this project become a PCB? No, this project is only ever going to be a breadboard and a sort of Arduino sitting to one side, some of these MOSFET drivers, power supplies, various measuring devices, potentiometers. Now on Muppet 1, I kind of fixed all the Arduinos and pots and measuring devices on one piece of board. But I figure this stuff's going to change so much that I thought I'd do the breadboard for the high power components, because they're quite hard to sort of put down, and everything else just sitting on the bench. I begging you get an isolated gate driver. Well, these are isolated gate drivers because they're opto-isolators, so they're isolated. They're not ideal MOSFET gate drivers because they're slow. And yes, I could get gate driver ICs, but then I'd have to sit down and work out how they work. So I have bought some IR210s, I think they are, but I've never played with them. And I like these because they're visual. You've got LEDs, you can see what they're doing. Can you double up the Schottky diode? We could, but I don't think that would make any difference because someone was saying that they thought if you put two Schottkys in parallel, you'd get half the forward voltage. No, I don't think you would. You'd get the forward voltage of the one that had the lower forward voltage, because you can put a Schottky in parallel with a standard silicon diode. I did that at the beginning of that last video. Actually, no, it's the beginning of the video where I did these efficiency tests. And the Schottky was the one doing the work because it has the lower forward voltage. So, no, I mean, if you could stack diodes in parallel and reduce the forward voltage by doing that, then that would be a thing. You'd see Schottky diodes stacked in parallel everywhere, and you don't. So, no, that doesn't work, unfortunately. Can you explain more about those two opto-isolators? Yeah, possibly. They're simply complementary. So the Arduino drives one of them when the output is high and the other one is off. When the output goes low, it flips across to the other one being driven. So it's either one is on or the other, depending on the signal coming out of the Arduino. And who disliked this stream? Yeah, don't worry about dislikes. Dislikes are good because dislikes are engagement, so I'm not worried about those. Prefer likes, but I don't mind. In fact, I can't see dislikes on the screen here. I can only see likes. 37 likes. Hey, I tell you what, everyone like this video. Let's see if the likes go shooting up and we can overwhelm. How many dislikes has it got? I can probably see that on the... No, I can't find it at the moment. Let's get the likes up. That's more like it. Yeah, so one of these optos is on, the other one is off. That's always the case. They just simply flip. There probably is a very, very tiny deadband because it requires that the voltage is quite far one way to turn one of them on and quite far the other way to turn the other one on. So there's probably a tiny deadband, but it's going to be nanoseconds. And then simply the other side, the two middle pins are connected together. So it either shoves 9 volts on the MOSFET gate or it shoves 0 volts and actually shorts the MOSFET gate out. So one of the transistors will pull the gate rapidly up to 9 volts, and when the other one goes on, it'll pull it rapidly down. And that's the whole thing about driving MOSFETs. You have to pull them up quickly and pull them down quickly. Charlton has another question, done as a super chat, which I'm not complaining about. Any plans to get rid of the 9 volts and implement a single power source for all components, or are you not bothered? Well, I'm not really bothered while this is just a breadboard and an experimental test rig. I did get some little isolated switch mode power supplies, which generate, I think, 12 volts from a 5 volt input. And I could use those instead of the 9 volt battery. They'd simply take the 5 volts, because 5 volts is available on the input here. I think it's the outer two connections are VCC and ground. Generate a little 12 volt power supply and use that to replace the 9 volt battery. But they'd be noisy because they're switch mode. 9 volt batteries are noiseless. The amount of power that's being pulled out of these 9 volt batteries by the optos repeatedly charging the MOSFET gate and then discharging it is fairly insignificant. So they last forever. What's this? Not only low speed on opto, but also slow gate drive due to low current. Well, it's moderate current, because when the opto transistor turns on, you are pushing the gate of the MOSFET up through that transistor to 9 volts and then back down to 0 volts. Okay, they don't turn on very hard because it is only being turned on by light on the base, not a voltage on the base. But they're okay. They're good enough, and I like them. They're visual, and they're my design. Why would I not like them? Thank you. I love your channel and your vids. Thanks, Christopher. Right, now, output capacitor. Yeah, that's a good point. So Nicola probably is saying you should use an output capacitor. Well, I will when I need to. Now, I don't need to with a bulb here, because the bulb kind of absorbs. The output's very ripply. We saw that on a previous video. And the bulb just absorbs that thermally. So it's almost like a thermal capacitor. John says, I wonder if you could improve the efficiency by replacing the Schottky with a MOSFET sequenced to allow current to pass without loss. Well, that's exactly what I'm doing, of course. When I'm doing the... I mean, there's no Schottky here now. Let's just tip this down a bit. In my buck converter diagram, here's the diode. Well, that diode is this MOSFET. Now, if I turn off the drive, it's difficult to see everything at once, but if I turn off the drive to the second MOSFET, it's just acting as its own body diode, so it's not doing a lot. But if I turn that drive back on, and I've got to get this done right so I don't overcook the... So if I now drive that MOSFET, then of course there is very little voltage drop across there, because it's only the RDS on the resistance, well, V equals IR multiplied by the current will give you a tiny little volt drop across there. Yes, so the circuit diagram is actually not quite what I physically got. Yeah, you're right, John. At the moment, I mean, this does have a diode. It has the body diode, but it also has a MOSFET. And yes, it is being switched. You can see the green lights there. And so we've got an active high side switch and an active low side switch on there. How many Muppets went into making this? None. Greetings from Cyprus. Gate drivers have peak currents from hundreds of milliamps to amps. So MOSFET switching well under 100 nanoseconds. Yeah, I mean, absolutely right. Gate drivers, MOSFET gate driver chips are designed for driving MOSFET gates, and therefore they will be fast. And therefore, if I use proper gate drivers, I'd get much better efficiency. But guess what? From now on, I'm not really bothered about efficiency. I don't really care. I'm going to completely drop all this efficiency stuff, because what I'm really interested in is getting the sequencing, the waveforms. Let's tip the phone back up to there. I want to get suitable waveforms coming out of some sort of processor to switch 4 MOSFETs in a sequence that will give me either buck or boost, depending on what voltage I have left and right. And and I want to be able to transfer energy left to right or right to left. It's really just getting these waveform sequences right so that I can do what I want to do. Now, I don't really care if this thing is massively inefficient. It doesn't really bother me. I want to be able to take a capacitor, supercapacitor, this side and another one this side, transfer energy from one to the other. Now, that'll mean that at some point their voltages will meet, and therefore I'll have to switch from buck to boost and then shovel the energy back the other way, because that's what this is all about. It's about pushing energy from one side of the unit to the other. How long are you discussing this Muppet? And get back to the other topics. Well, this is Muppet 2 Live, so I will be talking largely about what we're seeing here, but I don't mind going into some other topics, like, Julian, what is your age? 57. Richard Sheets has just donated $2. Thanks very much, Richard. I'm 50 something. Yeah, I'm 57. I was born in February 61. So I'm 57 and a bit. Cold, wet, rainy York. Yeah, I think probably most of the UK is cold, wet and rainy. Scotland apparently is quite nice. But yeah, I was actually quite cross yesterday when it rained the entire day and I just couldn't do anything. Where did I go to university? Well, before universities, we had things called polytechnics, and I went to a polytechnic. I actually went to Lanchester Polytechnic, which is Coventry. But I was only there 2 years, and I don't have a qualification from there. I'm a dropout. Julian really wants to move to some island in the Mediterranean. That's correct, because that particular island in the Mediterranean is sunny all the time, and that would be pretty good for this sort of project. Do you plan a sort of constant current mode for the Muppet 2? Well, if you mean supplying a constant current to a load, you can do that by measuring the current and adjusting the voltage to maintain that current. And to adjust the voltage on the output of a buck converter, you would need to have control over the duty cycle. So the Arduino would control the duty cycle, look at the current going out to the output, and just simply make adjustments to the duty cycle to maintain that current. That's a feedback control loop. Now, if you want this device to be a buck regulator as opposed to a buck converter, then you would want some sort of feedback control loop to hold the voltage at the output constant. If you want constant current, you'd measure current and have a feedback control loop to hold the current at the output constant. You can have feedback control loops for voltage and current on the output. You can have feedback control loops for voltage and current on the input. You can have feedback control loops wherever you want. Then, of course, you've got to do control engineering, which means you've got to worry about stability and overshoot and critical damping and all that sort of stuff. And actually, when I was at college, I was doing a course called, what was it called? Computing and Control Theory, I think, or Computing and Control Systems. So we did do feedback control loops, and I kind of took in some of the stuff. Do you use PID for the control? Well, you can use PID, but you can build feedback control loops without PID if you want. So yes, I got an awareness of feedback control loops, but I didn't really fully understand what was going on at the time. And it was the early days of feedback control loops. I think it was the first time they'd ever run the control theory course. Are you planning on doing other things in the future? That's a pretty broad question. Yeah, I'm planning to do lots of things in the future. Do you mean other projects? I mean, I've got what I suppose are my three main projects. I am planning, actually, Mr. Komosky, because I know you ask about vocoder. I am planning to get back into the vocoder, and I've now come to the conclusion that the only way I'm going to make any progress with the vocoder is to build some printed circuit boards for it. So I'm going to try and think how I can do some, what would you call it? A PCB for the vocoder, which I can use multiples of. A modular, that's the word I'm looking for. Make the vocoder modular to an extent. Yeah, that's what I'm thinking of doing. Vocoder bandpass vocoder. Yes, it has. It's a vocoder designed from the 1980s, in fact, from 1980. And it has 14 bandpass filters. 14 input bandpass filters and 14 output bandpass filters. So 28 bandpass filters it has. Will it be one PCB or a main PCB? No, I'm thinking of doing it as pairs of channels, because the chips, the VCA chips, are used for 2 channels, because half the chip is on one side and half's on the other. So it'll be a board that will cover 2 channels. So there'll be 7 boards to cover the 14 channels, and then there'll be a few other boards mounted vertically on the front panel to do the other things like output amplifier, input amplifier, mixer, noise generator, that sort of stuff. It is going to be a daunting effort, but actually, if it's modular, then designing the PCBs. I'm going to make a Z80 computer. Well, I've got a Z80 computer. It's in the shed, and one day I'll dig it out. It's just that I can't bring it into the workshop because there simply isn't space to lay it out. And when it's all laid out, it would take this entire desk. You're only seeing about what's that? Oh, you're only seeing about a quarter of the desk. It would just fill it, and I just don't have the space. Have you ever thought of going to one of Big Clive's meetups? Yeah, I did actually think of that the other day. I was thinking, should I go? But it's on the Isle of Man. It's quite a journey. There'll be a lot of driving, and then I don't know whether you can get a ferry. I presume you can get a ferry, but it's not going to be quick, is it? So yeah, that wouldn't be easy. It'd be lovely to do, but it's just a bit far away, really. Okay, so we've got Morphoys has done a super chat, $2. Oh no, €2. Sorry. Greetings from Germany. Greetings, and a sunny icon. Is it sunny in Germany then? Yeah, little Clive, that would be me. Yeah, envious if it is sunny in Germany. It's not sunny here in the UK, I'm afraid. You should make a small robotic arm like the ones on factory lines and program it to flip pancakes. Yeah, not into that. There's things I'm not really into. Robots are one of them. Motor control, I've never really been into motor control. No, I just don't find it very interesting at all. I don't know why. I like this sort of thing. I like it where you've got lots of sort of bits all over the table and you've got to look at lots of things simultaneously. Let me my glasses back on because I'm looking at a screen 2 inches from my eyes and I can't focus on that very well. Flipping robot is called a wife. Yeah. No, not really. You should make a solar-powered AC. What's that, air conditioning? Absolutely no need for it in the UK. In fact, I don't have air conditioning in my car, and you don't need it. Maybe a couple of weeks a year, I would switch it on. In fact, I don't like air conditioning in the car. My mate puts the air conditioning on in his car in the winter, and it's freezing cold, and I'm constantly nagging him to turn it off, and he's going, oh, my window's all messed up. Don't need air conditioning in the UK. Have you any other YouTube channels you follow that are not electronics? Yeah. Who do I follow? I watch Casey Neistat now and again because he's king of YouTube. But that's really to get ideas on being a YouTuber. I mean, obviously there's no electronics there, but yeah, just to get some sort of ideas on being a YouTuber. Who else do I watch regularly? Oh, I watch Fully Charged Show, which is the one on electric cars. I suppose I should be doing something really. I was going to do the flip camera thing. Do you want me to flip the camera? It's pretty alarming, but let's flip the camera. Yeah, there we are. Yeah, I watch Fully Charged Show, which is Robert Llewellyn and Johnny Smith doing... Don't flip it, I flipped it. Doing car reviews, all electric cars, of course. Actually, I drove an electric car the other day. I went to Mercedes in Beaconsfield and I asked for a test drive on the Smart. for 2, and then my test drive was booked, and I turned up, and it was a Smart 4.4. So anyway, I thought, well, let's drive it anyway, because I'd never driven a fully electric. I've driven the Golf GTI hybrid, and it's very nice. I mean, it was what I expected it to be. And then there didn't seem to be much regen braking, so I said to the salesman, how do I adjust the regen braking? And he said, what's that? And I thought, oh, okay. So I had the wrong salesman, really. And then he said to me, he said, I'm not really a fan of electric cars. And I said, no, it would appear that you're not. So it was a nice drive. And then at the end, he was starting to say, so what do you think? And I said, well, I'm thinking of emigrating, so I can't really make a commitment either way. So that killed that, which was precisely what I wanted. You need to change the white balance. Your face looks powdered. Yeah, well, I haven't got a tan, you see. My tan, I was working on my tan, and then the sun went in, and electric cars are so ugly. Well, not if they're in the body of a car which has an internal combustion engine equivalent. The Leaf's ugly. I'd agree with that. The Leaf really is an ugly car. I think it's better now than the new version. But yeah, what an ugly car that was, the first version. Somebody said, Julian is just naturally sexy. That's why he looks to have makeup on. No, no makeup. No makeup, just haven't shaved. That's a normal UK complexion. Yeah, it is. Pale, no tan. Now, if I lived in the Med, I could get a tan really quick. Lots of cars are getting ugly, Adam says. Angular and nutty. Aughty. Don't know what that means. Jutty. Oh, I see, yeah. Yeah, things like the BMW i3 is quite angular and jutty. But there are beautiful cars as well. Can't wait for electric cars to totally take over. Yeah, it's going to take a while because we're still waiting for the capacity. And that's a tricky problem with batteries and supercapacitors and the like. Still nowhere near the capacity of fossil fuels, unfortunately. Right, now let's have a look. Is that why you have that electric bike? Well, I do have the electric bike, but there are two problems with it. One, in the winter it's too cold, and two, in the summer, too many flies hit your face. So there we are, two reasons why I don't often take the electric bike out. It's quite nice in, when it's very, very warm, but no, I don't often take that out. I want to rebuild the battery pack, actually. I'm not happy with the way I wired the balance cables. It's a mess inside there, and I want to redo that, but it's a lot of work. Got to take the whole thing apart, try not to short out the batteries. That would be bad. You should get a Renault Twizy. Well, I did think about the Renault Twizy, but it's really a single-seater, and that's why I'm now looking at the Smart, because that's a two-seater, the Smart 4.2, and it also has windows for when it is raining. The Twizy doesn't. Don't think the Twizy has air conditioning. See, I'm only thinking about the Smart in the Med, where it's warm, where I might quite like air conditioning. I wouldn't buy a Smart here. Sorry, Mercedes, but I'd never intended to buy that Smart in the UK anyway. Yeah, I quite like the Smart because you sit side by side. It's just a bit more civilized than a Twizy, where you can shove a person in the back, but it's inelegant, to say the least. Never thought flies were an issue in the UK. Yeah, they can be when it gets to the middle of summer. All electric is pointless at the moment unless you can charge it from renewable energy sources. Well, it's also not really very practical because charging is so slow. So let's take a petrol station where you've got 8 pumps, and people pull in, they fill their cars with petrol, they're in and out in 5 minutes. Now let's say you've got a electric recharge station with 8 recharge terminals. People pull in, they sit there for half an hour minimum to get the least bit of charge. You're only going to get an eighth of the throughput of cars in an 8-unit electric charge station as you do in an 8-pump petrol station. So there's a problem. Is in the background your right to the LAD message? Oh, probably. Yeah, yeah. Let me point to it. Oh, no, it's on this side. It's there. Yeah, that's an LED matrix, 7 by 64 LEDs. Vocoder project. Yeah, I've mentioned the Vocoder project. I will probably get back to that by designing PCBs for it. When is the next solar panel update? Solar panel update. Solar panel update. Well, probably when the rain stops. Charging in countries with large area and low population density have a long time to wait before charging stations make EVs practical. But then if you had lots of space and you could have very large recharge stations with, 100 recharge units, so you can have a lot of cars parked there all at the same time, that would work. You can't do that in the UK because there's not enough space here. New graphene battery can charge in 5 minutes. Yeah, that might be a sort of hybrid battery stroke supercapacitor. Very interested. Oh, actually, yes, going back to the question on which other YouTube channels do I watch Robert Murray Smith because he's doing some pretty amazing stuff in relation to batteries and supercapacitors using all carbon electrodes and non-poisonous electrolytes. Tika Mosky says, I owe you a $5 from the last live chat. Do you? You don't owe me anything. He's donated. Oh, the phone's ringing. It's going to be one of those stupid calls. Hang on a sec. Yeah, just a dial tone. Yes, where was I? Yeah, so thanks very much for the $5 Canadian, Mr. Kamoski. Oh, so you're in Canada, are you? Okay, I'll try and remember that. Where's the music? Music from the phone, you mean? No, that's a standard wall phone. PPI phone message. Well, it just was dead. And I don't speak. And if you don't speak, the robot calls just cut off, which is the quickest way to get rid of them. And then if it's a person on the other end, they have to speak to me first. Otherwise, nothing happens. Electric cars do not help the environment the same way as not having an option of public transport can prove there is no interest in public transport. G. Walker. You're not my mate, Grant Walker, are you? Probably not. Yeah, I mean, there's all sorts of arguments about electric cars, and cost of the energy, manufacturing energy, input, and all that sort of stuff. I'm not interested in all those arguments. John says you have to speak, then it goes to a human that you then ignore. Yeah, the trouble is then you get embarrassed about being rude. I'm not that embarrassed about being rude, to be honest. Right, let's flip the camera and put it back on the Muppet 2. That is, after all, what this live stream was intended to be about. If there are no questions, well, fine. I'll just twiddle this knob and watch the brightness of this bulb go up and down. By the way, for those people who have said, why don't you put a capacitor on the output? Well, I will. One day, I'll put a supercapacitor on the output. How about that? That's the biggest capacitor I can think of. Loving this live theme. Thanks. Yeah, I just find that the live streams work quite well on this phone. This phone has got a processor powerful enough to maintain the data streaming, and I can watch the. It's over there. I can watch the chat on my PC, which isn't fast enough to do live streaming. So I just plug in this phone. It's different to the phone I normally record on, although I probably could record on this phone. I do have open camera on this phone. Maybe I'll try making a video on this phone, and then I could just leave this phone in the phone holder, which just dangles down from a microphone stand, which is screwed to the desk. Yeah, I think you can see it there. You can see the screw where the microphone stand is screwed to the desk. Can you see the springs? Yeah, you can just about see the springs, which are holding the boom arm up. And then there's an upside down tripod head, which means that I can do pans like that. And then there's just a plastic phone holder, sort of £2 thing, actually holding the phone. It's as simple as that. Would you go around in a Sinclair C5 if you can get one? No, I wouldn't. For the same reason that I don't particularly like riding an electric bike around here, and that is when the trucks thunder past you at 50 miles an hour. It's really quite intimidating. So no, I don't particularly. No, I wouldn't want to. I might ride. I might quite like a trike because you've got the width, so that you're a bit more. You've got a bit more road presence. The audio is slightly off in Australia. Are you saying? Yeah, you mean the timing? Yeah, it probably is slightly out. That's probably the phone. It might be delays in I don't know, YouTube's streaming system. I don't know. Off the Muppet 2 project, I've now got most of the parts to make 10 Gumstick PWM5 chargers. Okay, yeah, let me talk a little bit about the PWM5. So this was my Gumstick printed circuit board because it's about the same size as a stick of gum. So, but that's not really my final design for the PWM5. I'm going to lose these connectors left and right. I'm going to shrink the whole thing down by putting some components on the underside and some components on the top side. I'm going to lose all the through-hole components. Well, apart from the MOSFET, I'm going to keep the MOSFET as a through-hole component. It's going to be massively smaller, about 1 inch by half an inch. I'm going to try and get it down to. Wires will come in and solder directly onto the legs of the MOSFET, so you won't need any sort of high current tracking on the board. It'll all be low current tracks. And that will be the final PWM5. Then you'll just take the little board, it's only 1 inch long, slip it into a bit of heat shrink, squirt a bit of clear, when will you start Muppet 4? Yeah, a bit of clear sealant in, because this time I'm, rather than just sealing both ends and leaving the electronics in an air void, I'm thinking of actually squirting sealant right through so that all the components are completely encapsulated in sealant. That might give it a better chance of not taking in moisture. And that will be the PWM5, and then that will be the final design. There's really nowhere to go after that. I just want to make it the smallest pulse width modulation solar charge controller in the world. Can you daisy chain PWM5s? No, you can't daisy chain them. You can put them in parallel, but not at both sides. So you can put the battery side of 2 of them in parallel, or 3 or 4 actually. But then you have to have separate solar panels on the other sides. You can put the solar panel sides in parallel and feed them from one solar panel, but then you have to have multiple batteries. That works. You can't actually put them in parallel because one, it's like putting diodes in parallel. One would do all the work, the other one would do precious little. Off topic. Balance charger discharger for LiPo, LIHV, LIFV, ion NICAD, NIM, PB worth having. Well, it's worth having a balance charger for all those chemistries. But I wouldn't make one because you can buy them. But you can't buy a bidirectional. Well, maybe you can. I did see it was an LT7805, I think, which is a buck boost full MOSFET configuration module, and it has a direction pin. And I bought it and I paid for it, and it never turned up, and I got a refund, and I've not looked at it since. But maybe I'll take another look at the LT7805. Because it is essentially what I want here. It's got all the feedback control loops as well. It's fabulous. How many watts can you maximize output? Do you mean on the Muppet 2? How many watts could I put through this? Well, I could put a lot of watts through this inductor. It's got some pretty heavy duty wire on it. It's really down to how hot I want these MOSFETs to get. They don't have heat sinks on them, so I've put 5 amps through these and they get warm. Any more than that and they'd get hot, and then I'd need heat sinks. So yeah, it depends on how much heat sinking you want to introduce. Right, what else have we got here? How much money did that torch with your name on it cost? Oh, I think it was about £20, something like that. Oh, and Adam's not only talking on my live stream, he's also put a video up. I shall have to watch that. Adam Welch. Go and watch Adam Welch's video. I'm going to finish this live stream. It's 45 minutes. I'll finish it within the hour, I think. Lots of rain forecast for tomorrow. Yeah, sad face. Yeah. What's the maximum or minimum volt you can use on this Muppet system now? Well, again, voltage is really dependent on when these MOSFETs start to get cross. I can't remember what their maximum drain source voltage is, but I suppose it's going to be something around 40, 50 volts. I probably would never take this over about 24 volts. There's just no point, because I'm going to use it for batteries and supercapacitors. The supercapacitor modules I have are 16.2. All the batteries I have are 12, maxing out at about 14. So I'll probably work within the 0 to 20 volt range. No rain in San Diego. No, that doesn't surprise me. I doubt there's any rain in Nairobi, Kenya either. Zulu. No, you've probably got sunshine there as well. I did that yesterday, Adam says. Yes. Okay. Oh, that's just my notifications are incredibly slow. My Google Chrome notifications. I don't know why they're so slow. Oh, okay. That was a yesterday video, was it? Sorry, Adam. But anyway, watch Adam Welch's videos anyway, because he does all solar 12 volt stuff from his solar shed. All good stuff. Would you dare put a 100 watt LED bulb in the Muppet system output? Not really as it stands, because you've got to be careful with LED. I'd probably put a 50 watt halogen on there, but LED, you've got to be careful that you can very quickly get into high current, so you'd have to be quite careful monitoring the voltage on the output, and it'd be quite easy to just shoot way above the voltage, which gives you a reasonable current, overcurrent it, and causes complete system destruction. In other words, the difference in voltage between low brightness and high brightness on an LED is not that much. Bulbs are just much more manageable. Yeah, if I finish my live stream, Adam says he can finish at the gym. He's getting tired. Well, hang on in there for another 5 minutes or so. Could I use a 24 volt panel to charge a 12 volt battery? You could on this, yeah. Because this is switch mode, yes, you could put a 24 volt panel. In fact, I've got a 24 volt panel. Well, of course, I've got 12 volt panels, which I can put in series. So, yeah, that'd be quite interesting, wouldn't it? To put a 24 volt panel, which would have an open circuit voltage of, probably pushing 40 volts. And buck convert that down to 12 volts, either for a 12 volt bulb, which is what this is here, which is quite hot, or a 12 volt battery or a supercapacitor, which you could sort of limit at around 12 volts or 15 or 16. But yeah, I mean, because of the step down when it's buck, this is currently configured buck with the 2 transistors in front of the coil, the inductor. When I go to boost, you'll see that the circuit for boost has the coil first, I think, and then the switching MOSFETs here afterwards, and then there's a diode here, which can also be a MOSFET. If you want to do synchronous boost, you can put a MOSFET in here, and you can just use a dual MOSFET for boost converter. And in fact, that's where I'm going to go with this next. The next thing I do on here will be boost. Actually, it'd be interesting to find the little diagram for boost. Maybe I could sketch one out really quickly, just from memory. If I can find a piece of paper. Yeah, as I remember it, the boost circuit is inductor, switch going down here, and diode on the output. It's that. Now, this is interesting. Say you've got your input feed here coming in. What happens if I switch this MOSFET to 100% on? Oh dear, dead short through the inductor and the MOSFET. So one of the things about the boost circuit, when I've got a switching MOSFET here and a diode there, that diode of course can also be a MOSFET, is do not switch the transistor on 100% of the time, because that's the dead short. And so what I'll probably do is I'll use the Arduino constrain command and say, okay, take the pot value and put it out to the PWM, but constrain it to something. I don't know. I mean, maybe 50% is going to be too much. I mean, I'm going to start off by switching this MOSFET tiny amounts. It's just going to have a tiny on time. So I'm not quite sure how much on time you have in a boost converter. The other thing is I'm not sure whether you get a constant voltage output. And will I need a capacitor on the output? Yeah, so lots of interesting questions about the next stage in this, which is to build boost converter circuits, because I'm pretty much done with buck now. I'll do non-synchronous boost, then I'll do synchronous boost. Then I'll try and do buck on this side and boost on this, raise the buck up to 100%, and then wind up the boost so that we go from a step down to a equal voltage on either side to a step up. So much to do, and it's going to be incredibly interesting. So I'm looking forward to all that. Why don't you get things started? It's time to get things started. Okay, yeah, I mean, I want to get on with these things, but other things get in the way, like postbag videos and product reviews and stuff like that, and all the other projects like 8-bit computer. I want to get back to that. Oh, we need a moderator now. We've got a silly person making stupid comments. Can I moderate this person? How do I block hide user on this channel? Silly person hidden. Okay. I need a mod. Yeah, there are a couple of mods. I don't think they're on at the moment, but that person has been blocked, so no problem. Anyway, I think I'm going to call it a day on this live chat. I just wanted to do some stuff on some of the questions that came up with regard to efficiency and MOSFET drivers and that sort of stuff. Say hi before you go. Hi. Yeah, well, we get stupid people making stupid comments. I get stupid people making stupid comments in the comments on the videos, but that's just how the world is. Yeah, so really, I think I'm kind of done with buck because we've done non-synchronous and synchronous buck. Next step on this project, boost, and then bit of buck and boost, which I think is going to be interesting stuff. And then, of course, I want to try doing some stuff. I mean, it's really easy. It's just switching the MOSFETs in a different order, where we try and transfer energy from the right side to the left, or from the left side to the right. If both devices are storage devices like batteries or supercapacitors, then we can start playing with bidirectional stuff. Right, okay, well, I think that'll do for this live stream. I'm going to do more live streams, so they will pop up from time to time. They probably work better in the evening, but then I don't always have a quiet house in the evening. The house, and it's very difficult to pre-plan a live stream because I can't really pre-plan when the house is going to be quiet, which is why I did one now. But yeah, thanks very much for joining me, everyone. Thank you to the people who have made super chat donations. They're always appreciated. Thank you to everyone who hasn't put silly messages up in the chat. And thank you for joining me on this Muppet 2 live stream. A new Muppet 2 video coming up soon. But for the moment, cheerio.